an independent editorial defense analysis examining the United Kingdom's military strategy.
The kinetic validation of the Challenger 3 main battle tank at the Lulworth Ranges represents more than a mere technical milestone in a procurement timeline. It serves as the audible confirmation of a fundamental shift in British land warfare doctrine. This marks a transition, a move away from a philosophy of unique, national-specific engineering toward one of deep integration within the broader NATO architecture. While the successful firing of the 120mm L55A1 smoothbore cannon, with a crew inside the turret, demonstrates that the integration of a German weapon system onto a heavily modified British chassis is mechanically sound, the strategic implications extend far beyond the technical specifications of the vehicle itself. The program encapsulates a tension. It is the tension between the desire for sovereign industrial capability and the operational necessities of coalition warfare. All of this is constrained by a force structure that prioritizes technological sophistication over mass and resilience. Central to this analysis is the decision to abandon the rifled barrel. This distinct feature, utilizing separate loading ammunition, has been a hallmark of British tank design since the Second World War. Its replacement by the smoothbore standard, common to allies such as Germany and the United States, is not merely a hardware swap. It is a concession to logistical reality. By adopting the L55A1 gun and its associated single-piece ammunition, the British Army effectively trades the specialized utility of the high-explosive squash head round. In exchange, it gains the superior kinetic energy penetration of modern fin-stabilized discarding sabot rounds. From an operational standpoint, this eliminates a long-standing vulnerability. British armored units will no longer require a unique supply chain distinct from their coalition partners. In a high-intensity conflict scenario in Eastern Europe, the ability to draw upon a common pool of allied ammunition stocks offers a strategic resilience that a unique national stockpile could never provide. However, this interoperability comes at a cost. It removes the versatile demolition capability that the rifled gun previously offered. This suggests a narrower focus on anti-armor engagements as the primary role of the main battle tank. The integration of the trophy active protection system further illustrates the reactive nature of modern procurement cycles. The conflict in Ukraine has demonstrated that passive armor, regardless of its thickness or composition, is insufficient against the proliferation of modern anti-tank guided missiles and loitering munitions. The decision to fit an active protection system acknowledges a hard truth. Survivability now depends on intercepting threats before impact, rather than absorbing them. Yet this addition introduces complex trade-offs regarding weight. The Challenger 2 was already among the heaviest main battle tanks in service. The additional mass of the Challenger 3 configuration has implications for strategic mobility. The ability to transport these vehicles across the continent, particularly over Eastern European infrastructure that may not support vehicles exceeding 70 tons, becomes a logistical constraint. This highlights a physical disconnect between the tactical desire for maximum protection and the strategic requirement for operational agility. Beyond the technical dimensions, the most significant structural constraint revealed by the program is the fleet size. The reduction to just 148 hulls signifies an acceptance of risk regarding combat endurance. In a theoretical context, a fleet of this size supports barely 2 deployable armored regiments. There is little to no allowance for a strategic reserve, or for battle casualty replacements. This creates a brittle force structure. In previous decades, and the loss of a dozen tanks might have been absorbed as a tactical setback. With a total inventory of 148, such a loss represents a degradation of nearly 10% of the entire national capability. This lack of depth suggests that the British Army is evolving into a force designed for high-impact, short-duration engagements rather than prolonged, high-attrition conventional warfare. It forces a reliance on Allied mass to absorb the brunt of a conflict, while the British contribution provides a concentrated, high-quality specialist capability. This numerical constraint also places immense pressure on the reliability and availability of the fleet. When the total force is this small, the availability rates must be exceptionally high to generate a credible deterrent. The industrial strategy underpinning the program is therefore critical. Centered on the joint venture at Telford, the decision to remanufacture existing hulls preserves sovereign heavy armor skills. However, the supply chain for critical components, such as the smoothbore gun, the active protection system, and the digitized architecture, is largely international. This reality challenges the notion of strictly sovereign independence. It reveals that the ability to field this capability is contingent upon the stability of international supply chains and diplomatic relationships with key industrial partners. Furthermore, the digitization of the platform indicates a shift toward a network-centric approach. The tank acts as a node within a larger sensor-shooter complex. The architecture is designed to share data with other assets, such as Apache attack helicopters and long-range precision fires. This connectivity is intended to act as a force multiplier. Theoretically, it allows a smaller number of tanks to achieve the battlefield effect of a larger force through superior situational awareness. However, this reliance on digital integration introduces new vulnerabilities in the electromagnetic spectrum. If the network is degraded or denied by electronic warfare, the combat effectiveness of the reduced fleet could be disproportionately impacted compared to a larger, more analog force. The financial aspect of the program, valued at roughly £800 million, reflects the high cost of modernizing legacy platforms. It raises valid questions regarding the efficiency of upgrading aging hulls versus the acquisition of off-the-shelf alternatives. The choice to upgrade preserves the domestic industrial base, but it also means the British Army is effectively fielding a new turret on a refurbished automotive system. This approach carries inherent technical risks regarding the aging of the base platforms and the integration of high-power electronics into a hull originally designed in a different technological era. Ultimately, the Challenger 3 program epitomizes the current dilemma of medium-sized military powers. There is a clear tension between the ambition to maintain a full-spectrum Tier 1 armored capability and the resource constraints that limit the scale of that capability. The resulting force is technologically advanced, it is logistically interoperable with key allies, and it is industrially sustainable. Yet, it lacks the mass required for independent resilience in a major conflict. The United Kingdom has effectively chosen to prioritize the quality and connectivity of its contribution to the NATO alliance over the capacity to sustain independent armored operations. This suggests a strategic calculation, that the future of British land power lies not in standing alone, but in providing a highly capable, albeit numerically limited component of a larger integrated coalition force. It is an acceptance of the risks that come with a lack of strategic depth in exchange for technological relevance.